Hi guys, and welcome back to my third tutorial on Pytorch. In this tutorial we are going to do multivariate regression or multiple regression, whatever you want to call it. Basically when we worked on regression previously, we had only two variables, the x and the y, right? So that is like y is equal to mx plus c. That's the basic of linear regression. Now in multiple variate regression, it is m1 x1 plus m2 x2 plus dot mn xn plus c. Okay, so we have multiple columns in our uh, independent part. So basically independent, there are multiple independent columns and one dependent column, that is our y. If you want to know further about it, you can always go to my blog and check it out. Okay, so what I did there was I used scikit-learn for it, and I did a test, did all those things in using a house price CSV file, which was a file for house price prediction. We are going to do something similar here, and we are going to work on the Boston house dataset. Uh, Before I start, I want to tell you that I am not at all prepared for this. I'm just recording the video at this moment. It's live, so pardon me for my mistakes, and let's start. So first thing we need to do is import the dataset. So we'll do it from scikit-learn.datasets, import load Boston, and let's name it Boston equal to load Boston. So let's see what is there in this variable. So we have a data key which contains the values, and the target, which will be our independent variable. This is a dependent variable, and we have feature name, description, blah blah blah. I don't need those things. I need the data and the target. So x equal to Boston of data, and y equal to Boston of target. That should do us. Let's check x. Yep, that's it. Y equal to, yep, that's also done. Good. So that part is done. So we have our data here. Now what we need to do is define our model. Okay, so as I told you before also that there is a similar code snippet for all the Pytorch model. So this part will be similar as I told you before. So class, let's name it Boston regression. Okay, and torch dot nn dot module. Okay, I haven't imported torch. Sorry. Oh, I will import torch here. Import torch. Done. Torch dot nn dot module. So def init self and super of Boston regression comma self, and what you need to call is dot init. Similarly, we have to define the forward function, self comma x. That's it. That's it for the code snippet. Okay. Yeah, that's it for the code snippet. This part will be same for everyone. Now let's define our model. So self dot name it anything. I will link linear only. Linear equal to torch dot nn dot linear. The input dimension and the output dimension, like it, let's take it as an input, indim comma outdim, and here also indim comma outdim. That will do the trick for us. Now let's go for the forward model. So let's define out equal to self dot linear of x and return out. Okay, so as you can see, it's completely same as a linear equation, just a few bit changes. So first let's check what is the shape of x. It will be 13 columns and 506 rows. Okay, so now let's define our model equal to Boston regression, and our input dimension will be those 13 variables, right? 13 columns. So the shape of that, x dot shape of 1, and output dimension will be 1. Obviously it is regression, so it will be a 1. It's done with that. Okay, now let's define our loss function equal to torch dot nn dot, so MAC loss, right, mean squared error loss, and our optimizer will be SGD. Yeah, why not? So torch dot optim dot SGD, and let's pass the model dot parameters function, define the learning rate, which will, let's give a 0.01. Not a problem. So that goes for our now. Okay, one big thing we have to do here is you see the data. So it is scaled, almost scaled, but the y variable isn't scaled, right? So we have to scale this. We have to put it in a range of 0 to 1. Neural networks always take values between the range of 0 to 1. So for that, let's import from sklearn dot preprocessing import min max scalar, and min is equal to min max scalar x equal to mns dot fit transform. Okay, fit transform x dot mns dot fit transform y. Okay, it expects a 2D array and we are giving it a 1D array. Let's convert it dot reshape -1, 1. So let's see. Yep, it's definitely scaled between 0 to 1. And let's check x. It has already scaled, but still. Anyways, so that part is done. Okay, now let's go for our we can do one thing. We can add the train test function, right? We can divide x into train and test split and then work on it. So let's do that. From sklearn dot, this will be cross validation, import train test split and x train comma y train x test comma y test. I might be making a mistake here, have to see. X comma y, x train, fine, y train, see, it will be x train comma x test and y train comma y test. Now that's fine. So we have our train split, we have our text split, test split. So let's go for the training process. So let's give it a epochs equal to how much, 100 epochs, maybe 100 epochs, yeah. For epoch, in epochs, so same thing we did there, out equal to model of x train, right? Yeah, model of x train, but first this is numpy array, so we have to convert it into a torch tensor array. How do we do that? Similarly, torch dot nn dot variable, no, torch dot autograd dot variable and strain. So torch dot from numpy x train, and that should do the trick. It's giving error. Okay, again, so as I told you, it only accepts float 32 type objects, so we have to just do as type float 32 and it should work. Hopefully it should work, and it works. Okay, that's it. Now loss val equal to loss function of out comma our actual y train, and yeah, actual y train, that should give the loss function. Let's print out that loss val and say let's say that we want to plot that loss, how the loss is going. So what we do is just loss equal to like an array of it, and let's see how it works. And there's no require grads. Okay, same thing we have to do again. Just copy, command C, copy, paste. That should do us our trick. So let's hope it does our trick. As type float 32. Made some mistakes, I hope. Okay, another okay, so that's working. Don't think why this is not updating, because we haven't we didn't write the function to upgrade that. So we'll do that in a second. Let's just check it. Okay, so if you want to, okay, first let's complete this thing. Let's complete this, then we'll go to that part. So we have this one. Now optimizer dot zero grad and loss val dot backward optimizer dot step. So what these three functions are doing is it's telling us that this is actually updating the weights according to the sophisticated SGD. Okay, so when we run this now, see the values are decreasing. Okay, so we have trained our model. Now we can test it. Okay, let's test it first, then we'll go for okay. So for testing, we have the test data, prediction equal to same model of let's copy this one. This is the same same as this. Let's copy it up to this part. Command C, Command V, dot data dot numpy. So what will this do is it will get the prediction output, the data part of it, and convert it into a numpy array. See the predictions. Okay, we got the predictions. Now from sklearn dot matrix, right, import r square, r2 score, and let's check what r2 score does. Sorry, y2 and y pred. So let's go for y2 and y pred. Y2 is our x test. I gave this x train, right? Sorry, it will be x test, and so what will be y test comma let's run this first. Prediction that's giving a bad score. Okay, let's do it for 1000 epochs maybe. Let's check this out. What happens if we give it for 1000 epochs? Okay, now we get 58% accuracy. Oh, that's a relief. Now one thing was that I wanted to show you that loss plotting. So what we can do is, can't convert this into a list, right? Let's see if we can convert this into a list first. I'm sure it will give a very bad output. Okay, we can't do that. Okay, yeah, so what we can do is it's okay, this will just print what is the epoch comma loss, and after this all of this stuff. Okay, we can do this here also, just loss dot append loss val dot detach dot numpy. Okay, so this should work. Let's see for what is the value of loss. Okay, does what numpy look that well. Maybe loss value of 0 should work. Yeah, so basically it's loss val dot detached dot numpy. What loss val dot detached is, it converts this, detaches this and then converts into a numpy array. Okay, this line will convert this into an array and we will get this. See, now if we run loss, this is our loss function. Let's plot this one and see how loss is working. So import matplotlib.pyplot plt and plt.plot a loss, and this will be a loss. Okay, just increase of figure size dot figure size, let's do it 16,8, so bit better to see how this value is decreasing constantly. Say let's increase our to 5,000 and let's see what happens. Okay, kernel run all. Okay, it's running. Take a few seconds to run. Okay, so see, for 5,000 epochs it's basically after 2000 it's the same, and if you see the score is 67%. So that's it for this tutorial. I will meet you next time. I will provide all the links to the github and everything. Bye.